Okay. All right. So trig ratios. There are 6 of them. 3 common ones. The first 3 are common, the one you're going to use most often. These are also trig ratios, but we don't see them as often. Will you see them? Yeah, but do you see them as much as you see these 3? No. Okay. So we have sine, not sin, it's sine, cosine, and tangent. Those are the 3 main ones. But we also have cosecant, secant, and cotangent. Okay? So the first thing I put there was SOHCAHTOA. Some of you might remember SOHCAHTOA, some of you might not. Where does it come from? Well, it comes from sine equals opposite divided by hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Okay? Ratios are fractions, which can be changed to decimals. All ratios are just fractions. Okay? They refer to not the angles, but the sides. Okay, so we're talking about right triangles today. All we're talking about is right triangles. Okay? So right triangles have 3 sides, 3 angles. One of them is 90 degrees. The other 2, I have no clue what they are. I can figure it out, but I don't know what they are. Then you have 3 sides, X, Z, and Y. Okay? So the A, B, and C are the angles. X, Y, and Z are the sides. So when I'm talking about sides, I'm talking about X, Y, and Z. When I'm talking about angles, I'm talking about A, B, and C. Okay? So when we're talking about these guys here, these are the sides, X, Y, and Z. These are all the sides. Okay? So opposite. Opposite means across from you, directly across from you. Okay? If I'm here, the door is across from me. If I'm here, that door is across from me, right? Just depends on where you are. It's across. Okay? Adjacent means next to. Next to, right? My classroom is adjacent to Mr. Yates. It's also adjacent to Aguilar's classroom, Mr. Aguilar's classroom. Okay? Now, if I change classrooms, there would be other adjacent, right? So it just depends on where you are. The last one, hypotenuse. Hypotenuse is always going to be the one opposite 90 degrees. It's always the longest side, and it's opposite of 90 degrees. Okay, that one's a hypotenuse. Okay? So depending on what we have, that's the one we choose. Okay? So the first thing is let's review these guys. Let's review these guys. So let's use this triangle down here. Okay. So I'm going to create a ratio, a fraction for each of these. Each of these guys is going to be a fraction. Okay, so I need sine of A. So the first thing you're going to do is figure out where am I? I'm at A. Angle A. So angle A is up here. This is the angle right there. That's where I'm at. So I need sine. And I know sine is opposite over hypotenuse. Which side is opposite of A? Remember, I said side, not angle. What side is A staring at? Y. It's staring at Y. Not B or C, because those are angles. A is staring at Y. So that's going to be the opposite. So Y is going to go on top. Over hypotenuse. Hypotenuse is Z, because it's directly across 90 degrees. Okay. All right. Next one. So that's the ratio. It's the fraction. Okay. So now B, cosine of A. So I'm still at A, but I'm not looking for opposite over hypotenuse anymore. I'm looking for adjacent over hypotenuse. Okay, so if I'm at A, what side is adjacent to A? X, right? It's next to it. Some people in my last class said, well, isn't Z adjacent? It's close to A too, but Z's got another name, right? X is the one we want, adjacent. Z has another name, not adjacent, it's called hypotenuse, right? And that's what we need on the bottom. Okay, over Z. Okay, next one. Now we're switching spots. Now I'm not at A anymore. I'm at B. Okay, so I'm switching locations now. So if I switch locations, there's going to be different opposites, different adjacents. Okay, so so at B, tangent is opposite over adjacent. So opposite of B now is X. And adjacent to B is Y. Okay. Next one, still at B. What's opposite? So sine is opposite over hypotenuse. Opposite of B is X. Hypotenuse is Z. Okay. I'm going to skip E and F for right now. We'll come back to them, but let's go to G. Let's go to G and H. So for G and H, I go back to A. CSC is cosecant. Okay. Cosecant says hypotenuse goes on top, opposite goes on the bottom. Okay. So hypotenuse is Z, opposite is Y. Z over Y. Okay. Secant of A. I'm still at A, right? Ethan, I have your focus up here. There we go. Okay. Secant is hypotenuse over adjacent. So I'm still at A. Hypotenuse is still Z. Adjacent is X. So what I want you to do now is do the last three. Do the last three that we haven't found any for. If you haven't already, do those. So if I'm at B, cosine of B, so I'm not at A anymore, I'm at B. Cosine. Cosine is adjacent, so adjacent to B is Y over hypotenuse. Tangent of A, so I'm going to go back to A. Tangent of A is opposite. Opposite is Y over adjacent is X. And then the last one, cotangent. Cotangent is adjacent over opposite. Adjacent is Y over X. On a test, this is what I would ask you. Which ones have the same ratio? Which ones have the same ratio? So yeah, let's say cosine of A equals sine of B. Good. Which other ones have the same ones? Sine of A equals cosine of B. Right? Is there anything else that has the same? Tangent of A and cotangent B? Yeah. Tangent A equals cotangent of B. Yep. They have the exact same answer. Same fraction. Okay. All right, that's the basic idea. So now how are we going to use those? We're going to use them to solve questions on the back. Okay? So now that we know how to find those guys, we're going to use them to solve. Okay, so let's go to the back. First thing, Pythagorean theorem. Pythagorean theorem, you learned back in 7th grade. How do I know that? Because I used to teach 7th grade many years ago. I taught 7th grade, and that's one of the things that we did was Pythagorean theorem. Okay, and then in 8th grade too, and then in math too as well. Okay, so sometimes it's called a squared plus b squared equals c squared. Sometimes it's called that. I don't call it by that because people get confused. Which one's A? Which one's B? Which one's C? Right? So what I do is I call it leg squared plus leg squared equals hypotenuse squared. Legs are the two sides that make up 90 degrees. So the yellow ones are the legs. And the purple or pink is the hypotenuse. Sometimes it's hard to tell what are we trying to find. When do we use Pythagorean theorem? When I don't, first of all, it has to be a right triangle. And when I'm missing a side, one side. Not two, I'm missing just one side. So example number 2, it's a right triangle, and I'm missing a side. I know it's a leg. How do I know it's a leg? Because it's part of the right angle, right? It's part of the right angle. So I know it's a leg, but I have to find it. Okay, so what am I going to do? I'm going to solve for it. So leg squared plus leg squared. So I know one of the legs is 10, so 10 squared. I don't know the other one, so I'm just going to leave it as a leg squared equals hypotenuse squared. Okay. 2 times the square root of 41 squared. And I need to solve for a leg. First thing, square it. 10 squared is 100. I don't know what a leg squared is, so I'm going to write leg squared again. This guy. Well, there's no plus in the middle, so I don't have to do a box, multiplication box. So how do I multiply this? This is how you multiply it. It's 2 times the square root of 41. So you're going to go 2 squared times the square root of 41 squared. Well, 2 times 2 is 4. What happens when I square root? It just goes away. So the square root of 41 squared is just 41. So when you multiply those two, you get 164, if my memory is correct from last period. So that's going to go back here. 164. So I need to solve for the missing part. Right? So it says the word leg. But really you could put an X there. You can put a letter there, right? So let's say that was a letter. How would I solve for that letter? Subtract, right? First thing I do is subtract. We've done this before. You guys got this. Subtract 100 from both sides. Legs squared equals positive 64. What's the opposite of squared? Square roots both sides, and you get the missing leg equals 8. Done. That's the missing side. Okay. Okay, so let's go to number 3. I got to find the length for x. I got to figure out what this is equal to. Okay. So I know that this is a side. This is a side. And this is hypotenuse. I can use Pythagorean theorem when I know 2 of the 3 sides. Do I know what 2 of the 3 sides are? I only know 1. So I can't use Pythagorean theorem right now. So what am I going to use? Well, they've given me another piece of information, right? They've given me another piece of information. They said, hey, an angle is 68. You got an angle that's 68. Okay, so I'm going to focus in on that angle right now. Picture it's the front. What would 96 be from the angle? Would it be opposite, adjacent, or hypotenuse? What would 96 be from this angle? Opposite, right? It's opposite. How about x? What would x be with this angle here? Would it be opposite, adjacent, or hypotenuse? Okay, so we said opposite and hypotenuse, right? Which one does that sound like? Sine, the first one, right? So what I'm going to do here is I'm going to say sine of this angle, which is 68 degrees, equals, we said opposite, right? Opposite that angle is 96. Hypotenuse is the missing side. Well, my calculator can figure out what sine of 68 is. I'm going to do that in a second. And I know 96. I'm just missing one thing. Take a wild guess as to how I would solve this guy. And I'll give you a hint. You've done it many times. You actually did it on your last test. How would I solve this guy? Multiply. What kind of multiply? Yeah, diagonal cross multiplication. Turn this guy into a fraction and do your diagonal cross multiply to get rid of the fraction. So on one side, I have sine of 68 degrees times x. And on the other side, I have 1 times 96, which is 96, right? How do I get x by itself? Solve, right? I have to get rid of the sign. I want to get rid of this guy. I don't want this guy over here with x. I want them broken up. I have 4 options. Add, subtract, multiply, divide. Which of those am I going to do with this guy here? There you go, because it's multiplying times x, right? So you're going to divide. I don't know what number it is, but I know it's not wanted over here. And this becomes a 1 because anything divided by itself is 1. Now you go to your calculator. Okay? So watch me do it, and then the next one you could do it on your own. So watch me use the calculator because there's a couple things that you want to make sure of when you're using the calculator. Okay, first thing, we want division. So 96. Sign is right here on the front. It's always on a calculator, so sign is always there. Make sure this says degrees though, because it's 68 degrees, right? The opposite of degrees is radians. Don't worry about radians, we'll talk about that later. But for today, we just want degrees, DG, okay? So you're gonna go sine of 68, close parentheses. That's our answer. Round to the nearest tenth, they said, nearest tenth. Okay, so the 5 is in the 10th spot. 5 is in the 10th spot. So I could stay at 5 or I could go up to 6. Well, the 3 says stay at 5. So 103.5. 103.5. And it makes sense because the hypotenuse should be bigger than the leg. Okay. All right, so let's do the next one. Okay. We got to find the missing side. So again, I only know one side, 9.5. If I knew another one, then I could use Pythagorean theorem. Wouldn't even have to worry about the angle. But I have to use the angle because I don't know the other side. Okay. So which one am I going to use? Which one of these guys am I going to use? What do I know? Do I know hypotenuse? Do I know adjacent? Do I know opposite? What do I know from the angle? Opposite. I know opposite, and I need to find adjacent, right? I know opposite's 9.5, and I know adjacent is x. Well, the one over here that has opposite and adjacent are these two guys. And if you have a choice, pick one of these three, because that's always easier to find on the calculator. These guys are on the calculator, they're hidden. So it's easier just to use tangent. Okay, so I'm going to say tangent of 23 degrees. Tangent 23 degrees. Tangent is opposite, 9.5, over adjacent, which is x. Okay. I'm going to turn this guy into a fraction, and I'm going to do my diagonal or cross multiplication. So I have tangent of 23 degrees times x equals 9.5 times 1, which is just 9.5. Solve for x. Well, I need to divide. So this one, you can use your calculator. So 9.5 divided by tangent of 23 degrees. $22.38, blah, blah, blah. Well, we want the tenths. We want tenths. 3's in the tenths. 8 says go up. So 22.4. Oops. 22.4. Okay. The last two, the only difference between the last two problems on your notes and the ones we just did are they don't give you a picture. You have to draw the picture. That's the only difference. So you just have to draw the picture. Figure out what is important, what's not important, and then solve the problem. Okay, so we're just going to do 2 more and then we're done. I'm not going to give you any extra problems. 2 more, we're done. Okay, so they're going to 2 things they talk about. They talk about angle of elevation and angle of depression. The difference is, hey, come on. Okay, so angle of elevation means when you look up. When I look up, that's an angle of elevation. When you look straight, that's a horizontal line. And then I look up, that's the angle of elevation. Angle of depression means when you're looking down. So if you're looking up at something, it's angle of elevation. If you're looking down at something, it's angle of depression. That's all it means. Okay, that's all it means. So you're going to see those 2 words. Okay. From her eye, which stands 1.69 meters above the ground, Sadie measures the angle of elevation to the top of a prominent skyscraper. So she's looking at the top of a tall building. Skyscrapers are just tall buildings. She's looking at the top of a building. So her angle of elevation, so that means her eyes are looking up 36 degrees. If she is standing at a horizontal distance, 275 meters from the base is the bottom. So she's standing 275 meters away from the building. How tall is the building? Okay. All right. So buildings stand straight up. Buildings like walls, they stand straight up. They don't curve. They don't make them standing like that because then they would fall over, right? So now, anytime they're building something, it goes straight up, right? Walls go straight up. Okay, so the skyscraper is going to be right here. Let me make it blue. Okay, that's the building, standing up. Okay, Sadie is over here. I'm gonna draw a little stick figure. She's over here. She's looking up at the building. She's looking, her eyes are up at the top of the building. So her eyes are going straight up to the top here. That's her sight. And then how far is she from the building? That's this last line right here. There's the triangle. So when the ground meets a building or when the ground meets a wall, it's always going to be 90 degrees. Ask anybody who does any kind of construction. When the ground meets a wall, it's always got to be 90 degrees. Okay, so that's our 90-degree angle right there. Okay, so let's see this. Her angle of elevation, so her angle looking up, her eyes, from her eyes to the top is 36 degrees. So her eyes are right here. From her eyes to the top of the building is 36 degrees. She is standing 275 meters away from the building. Okay. How tall is the building? That's what they want to know. Now, the first sentence says something about 1.63. That's how tall, that's how far it is from the ground to her eyes. That's not, we don't really care. I don't really care how far it is from here. I don't need it to make my triangle. So this part here, the 1.69 meters is not needed. Sometimes they'll give you extra information. I don't need it. Okay. So what I need to figure out is how tall the building is. Well, they've given me this. Which one of these guys' ratios am I going to use for that angle? I'm going to use cosine. Yeah, right, cosine. Because I know the adjacent, isn't that 275? And I need, actually, no, not adjacent, because I don't need the hypotenuse. I need tangent. Yeah, because I need adjacent, definitely adjacent from her, 275, but I also need the opposite. So I'm going to use tangent. So tangent is x over 275. Opposite over adjacent. Okay. Turn into a fraction, and it's the same thing we've been doing. Once you get to this point, you do the same thing you've been doing for the last couple problems. So 1 times x is 1x, and then I have 275 times tangent of 36 degrees. So this one doesn't even need any division because x is already by itself. I just have to multiply. The reason I divided the last two problems was because I needed to get x by itself. It's already by itself. So 275 times tangent of 36. Round to the nearest hundredth. 9 is in the hundredths. 9 says go up. So it's going to be 80, 199.80, 199.80. And it is meters. That's how tall the building is. Almost 200 meters, which is about 600 feet. Okay. All right, last one. Last one, then we're done. Again, read, draw a triangle, figure out what you need. Okay? So this one's not a skyscraper. This one is a ladder. So Hakeem's got a 26-foot ladder that stands up against the wall. Well, if I have a ladder, again, ladders don't stand straight up. If ladders stand straight up, they're going to fall over. They always lean up against something, right? So I'm going to draw. Ladders always lean up against something. What do they lean up against? Walls and the ground. So here's the wall. Here's the ground. Where wall meets ground is 90 degrees. It's not really a 90-degree angle. Draw this again. Oh, right here.
I have 2 more.
Oh, you got 2 more? Okay, sounds good. Okay, so we know that the ladder is 26 feet. That's how long. That's how long the ladder is. So that means this is going to be 26 right here. 26 feet. When the ladder is put against the wall, it makes a 72-degree angle with the ground. So where the ladder and the wall meet, or sorry, where the ladder and the ground meet is 72 degrees. 72 degrees. What's the horizontal distance between the bottom of the ladder and the bottom of the wall? Base means bottom. So what's the distance between the bottom of the ladder and the bottom of the wall? Okay. So 72. So I know I'm going to use 72. From 72, I have adjacent and I have hypotenuse. That's cosine. So cosine of 72 degrees equals adjacent over hypotenuse. Okay. Cross diagonal multiplication. Cosine 72 degrees. So I don't have to divide this one. No division needed because x is already by itself. So just multiply. Cosine 72. 72. Oops. 8.0344. Well, we got to round to the hundredths. So 8.03. 8.03. And it's feet. Okay.